book. You can see it's got the box around it. So they came from the lecture thing that goes along with your book. It says graph f of x equal the opposite of log base 4 of x plus 2 using transformations of y equals log base b of x, not by simply plotting points. Now the reason for that is that if you simply plot points, you're going to have to plot a lot of them to get the whole graph, because this guy shifted and flipped. Especially when you're dealing with left-right shifts, you could do the basics and only get a piece of the graph. Get maybe half of it. Maybe not even that much, because of a left-right shift. So that's why transformations come into play in that respect. So state the transformation that applied. Well, first of all, I always go after the basic function. And what's the basic function in this instance? Y equal what? Log to what base? Log base 4, right? Basic functions on logarithm is log base a of x, log base a of x, just like basic function on exponential is y equals a to the x. So it's going to be the log, and then you're going to say, well, how is that being transformed? Well, the first thing I do is always go into the parentheses first, order of operations. Put in an x value, you do something, then you take the log of it. And in this particular instance, what is the transformation using x plus 2? It's left 2, right, because this is a minus 2, so it's x minus a minus 2. That's how you got the plus. So this is going to be left 2, so we're describing the transformation. Clearly state the transformation applied. For me, it's easy to make a list, because then I know how I'm going to transform the function. And then I'm done on the inside. They've not done anything more to me. I come to the outside, and what does this thing do? He flips it, and so we say he reflects the x-axis. Or you could say he flips. But you're going to have to put x-axis in there, because you know you had a flipped across the y. So flip the x-axis. So what's that going to mean to me? Well, that means that if I'm going to be dealing with left 2, I'm going to take the x values and I'm going to add a negative 2 to the x values. That moves the whole thing to the left. And here, if I'm going around the x-axis are the y values. So this is going to be minus 1 times the y values. So that turns the thing upside down. So if I look at how this thing's going to work, I'm first going to rewrite and have this be that x equals 4 to the y power. Put in my favorite values. The more points that you plot to try to transform, the longer it takes you to do the transformation. 3 is pretty fast. You get into 4, you start to bog down. 5, you bog down even more. Don't know why. This is 1/4. 4 to the 0 is 1. 4 to the 1 is 4. So that's that bend in the graph. That's the bend in the graph. And I do have a VA at x equal 0. So I put that in. Left 2 means I'm going to add a negative 2, or you could say subtract 2. This is minus 1 3/4. This is minus 1. This is 2. This is minus 2. And now you notice the VA has been shifted to the left by 2. So I've moved from 0 to 2. That's your shift in VA. Now I'm going to flip by multiplying the y values by minus 1. 1, 0, minus 1. So notice everybody now's changed sign. And then that's my VA because he doesn't do anything. And what's on the new is what's on the outside. So if x equals minus 3/4, y equals 1. Minus 1 3/4, 1. And by the way, I forgot to put my VA in because that becomes important because the graph rides along it. This is x equal negative 2, so that's my VA. Negative 1 is 0. And x equal 2 is negative 1. Now here's my bend. That's why I only need 3, because that's the important part of that graph. He bends toward the VA, and he escapes the VA. So now he's going to ride up along the VA, and he's going to ride out. This is about as exciting as it gets.